Welcome to today's webinar, Production-Ready Container Networking with Red Hat and Big Switch Networks. My name is Angelique Medina. I'm Senior Product Marketing Manager here at Big Switch Networks, and I'll be your host and panelist for today's webinar. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video on demand and you have a question regarding today's topic, simply go to bigswitch.com/webinars and submit a question using the link provided. We have also provided you with handouts for today's session. The Big Cloud Fabric datasheet plus information on Big Switch Labs is available via the webinar dashboard. You'll also find several additional briefs that are relevant to today's topic. You can download them from the Handouts tab in the right-hand corner of your dashboard. Joining me today is Azhar Saeed, Chief Architect from Red Hat, and on the Big Switch side, we have Bala Ramachandran, Director of Product Management, and Ganapathy Bhatt, Principal Technical Marketing Engineer.
Glad to be here.
We have a full agenda for today's webinar, so we're going to get started. So what we're going to talk about in today's presentation is, again, production-ready container networking. We're going to start with an overview of the Red Hat OpenShift solution, and we'll also cover the drivers for that solution. We'll then get into the challenges around container networking and introduce you to the Big Cloud Fabric and Red Hat OpenShift joint solution. We'll also do a demo walkthrough of the solution, and finally, we'll leave time at the end for questions that have been submitted during the broadcast. So let's get started. I'm going to turn us over to Azhar Saeed, who will kick us off. Welcome again, Saeed.
Thank you very much, Angelique. Good morning, good afternoon, good evening, wherever you're in the world tuning into this webinar. We are really happy to co-sponsor this particular webinar with Big Switch Networks on container networking in particular. And initially, I'm going to just talk about the Red Hat container platform using Red Hat OpenShift. Next slide, please. You've heard about digital transformation. I'm sure you've heard about it from Red Hat. You've heard about it from other vendors. Digital transformation really requires an evolution in applications, in processes, and the infrastructure as well. It's not just about one component or the other. People need to look at new ways of developing and delivering and integrating their applications. They have to be much more agile and quick in terms of the delivery, which means process enhancements need to happen. And the infrastructure itself also needs to evolve. It's not just about managing nodes and networks the way it used to be, but it needs to be very, very different in terms of how you move forward in order to realize the vision of digital transformation. Next slide, please. Now, enterprise IT and telcos have a challenge in front of them. They have to evolve continuously to stay ahead of the demands that they see from their subscriber base, from their customers. And in that process, multiple things are happening. First, they need to evaluate what their development process looks like. The development process itself is evolving from the traditional waterfall model to a much more agile type model. Now, moving forward, that agile model is also not sufficient, that people are increasingly looking at DevOps environment where they're continuously building, continuously developing, testing, and integrating as things roll in production. So agility is what is really driving this particular conversation in terms of DevOps model overall with respect to implementations in the enterprise or telcos. Applications themselves, their architecture continues to change. Gone are the days when we were looking at monolithic applications or even n-tiered models where you had a strict hierarchy between different components within applications. Nowadays, applications are being reinvented through a microservices architecture and microservices model. And that microservices architecture and model are being delivered through containers. So containerizing applications is the big buzzword of today. Also, if you look at it from a deployment and packaging perspective, you are deploying that piece of software in a monolithic manner on a physical server or bare metal. Now, moving to virtualization, the same thing is being delivered in the context of virtual machines, and moving forward, packing much more density and much more scale with respect to containers. Now, the IT evolution, or the telco evolution, if you look at it, is to move faster, scale up in terms of densities, and move to a microservices-based architecture for the cloud. Next slide, please. So then let's ask ourselves, what are containers? I'm sure everybody has heard of containers. Everybody has a definition for containers. At a very high level, containers is a software packaging concept that includes application and its runtime dependencies, as opposed to virtual machines, which have a full operating system inside them and they run on hypervisors. The hypervisor context provides hardware abstraction, BIOS, and OS abstraction, whereas containers provide an abstraction of the user space to share the same OS and services as well as the hardware. So containers provide reasonable isolation between applications on the host operating system. They are much more lighter, hence you can pack many more containers onto the same system. Facilitate adoption of microservices overall. They're easy to add, and orchestration can be done through a very popular orchestration platform using Kubernetes. And more importantly, containers provide portability across from systems to systems. Next slide, please. So what is Red Hat's container set of solutions? Well, Red Hat Container Solutions is based on something called Red Hat OpenShift. OpenShift is part of the OpenShift origin community. But what does the Red Hat Container Solutions do? It allows you to modernize application delivery. It's based on standards, and it's fully automated with respect to frameworks. It provides increased agility in terms of delivering both your traditional applications as well as cloud-native applications. Have a common, consistency across your development environment, your test environment, your production environment, and provide the same gain across all of those particular environments. And the ability to build, applications in one form and deploy them either in private, public, or hybrid, cloud type of environments or data centers. Next slide, please. And the way we deliver our container solutions is through the Red Hat OpenShift platform. The OpenShift platform has the richest, set of frameworks that provide full application build lifecycle automation. I'll go through some of the features in the next couple of slides. They provide cloud scale, they provide isolation in the context of multi-tenancy, a full DevOps capability with CI and distributed CI as well as CD. CI is continuous integration, distributed continuous integration, and continuous development models. And of course, portability, because the format is exactly the same it's a container format, and we'll actually go through that in the next slide. Next one, please. So let me talk a little bit about, what Red Hat OpenShift is. How does it compare to some of the solutions that exist in the marketplace? Red Hat OpenShift is a complete DevOps platform for delivery of microservices-based architectures. It has full automation capabilities. It's web scale. It's standards-based. It's fully open source. It's 100% open source. It's an enterprise-grade platform. And the two key elements or two key big components of OpenShift platform is a Kubernetes-based orchestration model and the Docker container format. And we continue to work with Docker in the Open Container Initiative to adopt the Open Container Initiative guidelines. If you look at it from an OpenShift perspective, OpenShift has the following components. It has an optimized host in Atomic, which is actually an OS that's optimized to deliver and run containers. There are telemetry capabilities in terms of monitoring various different components within that particular platform. It's secure, provides isolation between applications. Security is built into the platform. It provides persistent storage capabilities so that you can run stateful applications as with containers on this particular platform. Full suite of automation and for full HA delivery and deployment. Now, if you look at the two different pie charts that you see, one on each side, on the left-hand side is a pie chart that talks about Kubernetes and Red Hat's contribution to Kubernetes overall. The biggest blue section of that particular pie is Google. As you all know, Kubernetes originated from Google. Google is the biggest contributor to that particular community. And the second largest, if you look at it from a company perspective, is Red Hat, the red slice of that particular pie. So we continue to work in that open source community to contribute to Kubernetes and improve, enhance orchestration mechanisms for containers. On the right-hand side, you will see the Docker contribution as part of the open source initiative. Again, the blue slice there represents Docker, and the red slice there represents Red Hat. And from a company perspective, again, we stand to be the second biggest company contributor to the Docker and now the Open Container Initiative format. Next slide, please. So one question would ask is, what's the value of OpenShift? Why OpenShift? Well, OpenShift really provides a way to improve your innovation to market. What do you mean by improving innovation to market? Well, it's not just about innovating something and leaving it there. It's about innovating something, making it, developing that, testing that, and making that deployable by customers. So expediting that particular process to market, accelerating your application development process itself, and increasing the overall efficiency of operations and enabling a DevOps infrastructure. OpenShift, we believe, is the platform for containers. It is 100% open source. Recently, there was a study done by IDC, and they've done some interesting analysis of OpenShift. And they found, they did this particular study, and they compared it to some of the other platforms, and they found that OpenShift provided 66% reduction in app development lifecycle. Almost from 28 weeks for a typical application that they were actually viewing that to do it in OpenShift to down to almost 10 weeks. They said that 35% less time in terms of number of hours reduction when using OpenShift, and almost 38% more cost effective with respect to annual infrastructure and development and solution development costs. So it is definitely the platform for containers. We sincerely believe that OpenShift is the way to go if you are thinking, looking, developing, and deploying containers. Next slide, please. Then comes the question, well, if I want to deploy containers, what are the components that I need to worry about? What are the things that I need to care about? Well, you need to care about lots of things. You need to care about things like lifecycle management, monitoring, persistent data storage, and so on and so forth. But today, for this particular webinar, we are focusing with Big Switch Networks on one very key element of, developing, deploying, and delivering using containers, which is networking. Container networking is an interesting, challenge in itself. Docker, Kubernetes provide a networking format and capability, and we need to solve that for a generic environment, for a generic purpose, and which is what Bala and team from Big Switch is going to walk you through. But really, in order to run containers at scale, network becomes the binding glue to running all applications at cloud scale, because you need to be able to scale horizontally and in a scale-out manner, as well as you need to be able to provide the isolation and security for that particular user data across that particular environment. So I'm going to pass that ball on to Bala next to talk to you about what are some of the challenges in container networking and how Big Switch Network is solving some of those problems. Thank you.
Thank you, Azar. Before we move on to Bala's portion of the presentation, I wanted to pause here and address a couple of the questions that have come in from the audience during your presentation. So we have a two-part question. It is, who uses OpenShift, and has anyone deployed it?
Thank you, Angelique. That's a great question. A lot of different types of customers use OpenShift, from the financial industry to the airlines communications to the telcos. Some of the names that, OpenShift.com, by the way, has all of the reference customers that are listed there. The customers like Amadeus, software development houses like Computer Associates, NEP network equipment providers like Cisco, FICO in financial space, and some of the telecommunications companies like Telstra, T-Systems, universities like Wharton, UPenn, UT Sydney, UNC Chapel Hill. And in the financial industry, one example that comes to mind right off the top of my head is AIX Capital. All of these folks have used OpenShift, and in particular OpenShift Container Platform, to deploy containers, to actually improve their DevOps models, and to convert their architectures into microservices.
Great. And finally, one more question we have time before we move on. Is OpenShift a full platform as a service? Can it manage bare metal or just containers?
So OpenShift is a full PaaS. It fills in the gap between everything that's required from application to everything that's underneath it. So it is a complete platform as a service. OpenShift can be deployed in, private cloud. It can be deployed in public cloud. It can be deployed in a hybrid manner. It provides a full catalog of capability. It provides full sets of frameworks. So it's a complete PaaS. In fact, I was actually just going through the different languages and frameworks that support databases that it supports. MariaDB, MongoDB, MySQL, Postgres, Node.js, .NET, PHP, et cetera, et cetera. So the list is really gigantic. It's a complete platform for your application delivery and for application development and to do DevOps.
Thank you, Azhar. We do have other questions, and we'll try to get to those at the end of the presentation. But now we're going to turn it over to Bala, who's going to go through some of the challenges that we find with container networks.
Thank you, Angelique. Thank you, Azhar. That was great. It was great to hear from you about the new container paradigm and about how Red Hat OpenShift is being leveraged as a production-grade solution for deploying containers. We'll now turn to what are some of the new challenges that are presented for networking when container-based applications are deployed. So as Azhar discussed, containers enable the new microservices-based model of application deployment. This is a distributed model, and it dramatically increases the volume of east-west traffic, even more than the VM-based environments where we have seen increased east-west traffic. Now, if we were to compare the deployment of VMs versus deployment of containers, if you look at a VM has one file system. It gets spawned in about 10 seconds. There are typically 25 VMs per server and 40 servers per rack. So you see density of around 1K VMs per rack. And typically you see one vSwitch per server, which handles the networking for all these VMs. For containers, they use a shared underlying file system, and that is shared across containers. They are lightweight and can be instantiated in sub-seconds. And so because of that, and as Azhar also alluded earlier, the density in a rack is a lot more with containers. And in addition, containers are a lot more elastic. They can be spun up or down rapidly. It's order of magnitude different from the virtual machines. And depending on the deployment model, it can have either single virtual switch on the host or nested virtual switches. So nested virtual switches is seen when containers are deployed inside a VM, where you have a virtual switch within the VM, and then you have a virtual switch for the VM. So you have such an environment. Now, given these characteristics of containers, what are some of the key networking requirements to consider when we deploy them? So typical networking constructs still apply. The physical network is there to connect the servers running the container applications, and they also connect to the external environment. So basically you have both east-west traffic across the different racks in the data center, and north-south traffic for traffic to the external world. And then the virtual network, which resides inside the server host. And additionally, you have the typical services that are needed for any application environment. So security as a service and load balancing across different containers as the traffic density increases. Now, as containers are rapidly spun up or down, the network needs to adapt to that rate of change. I mean, the change is really fast. So static configuration of networks will not work in this environment. And what is really needed is a very simple zero-touch networking environment enabled by automation of configuration. Also, when troubleshooting issues in such a dynamic environment, you'll need a way to rapidly identify if an issue is with a physical network or virtual network or with the containers or applications. Hence, having complete visibility of the environment and the traffic flow between the container endpoints is key for rapid resolution of issues. Now, when application teams deploy containers, they need an application-driven logical model for networking. They need a uniform model that applies across virtual machines, containers, and bare metal apps. In addition, service insertion mechanisms are needed as well. So these are all set of capabilities that the traditional box-by-box networking approach just cannot provide, but are mandatory for the deployment of container-based applications. We'll soon see how the big cloud fabric solution for OpenShift satisfies all these requirements and is the ideal solution for container deployments in production environments. But before we get there, let's look at the two popular networking models that are adopted by enterprises today. The first one is an overlay underlay model. So the overlay being a network of virtual switches. It leverages an encapsulation or a tunneling technology like VXLAN, and it runs on top of a physical underlay network, which does pure IP-based forwarding. Now, the other model is a unified physical and virtual network model where they are operating as a single logical entity, provisioned and managed as a single logical entity. Now, if you were to compare and contrast the two approaches, with the overlay underlay approach, there are two separate networks, two separate teams manage them. There's a performance penalty associated with the tunnel encapsulation decapsulation. There's an overlay underlay visibility gap, and of course there's the cost of paying for two separate networks. Now, with a unified approach, on the other hand, there's a single network, so the experience is uniform. There's typically a single team, cloud or networking team managing the environment. You can continue to leverage the normal networking constructs and isolation mechanisms without any encapsulation. And you also get single point of visibility into both the environments, which is a very big advantage when you look at the operational benefits that such environments provide. So next we will see how Big Cloud Fabric and Red Hat OpenShift solution offers a unified physical and virtual networking approach for container environments. So this is the Big Cloud Fabric solution with Red Hat OpenShift. So this solution is a unified fabric of physical and virtual switches. Now, the physical network is a leaf-spine cloth fabric of open networking switches, and it's managed by a central SDN-based BCF controller, Big Cloud Fabric controller, which extends the management also to the virtual switches. And you see that the virtual switches are noted as SwitchLite VX, and they are running on the host. The solution offers a vendor choice of open networking switches for building the physical network. There are no complex protocols that are run within the fabric, and the centralized SDN controller acts as a single pane of glass to manage the entire physical and virtual network environment. And host running containers, which are connected to the leaf switches, are automatically detected. Link aggregation groups are formed. The entire fabric is stood up in a zero-touch fashion. And it's also a very scale-out model. So when new hosts are added, there is no configuration required. And you'll see this live today in Ganapathi's demo about how easily you can scale up and down your container environment. And a BCF controller acts as a single point of integration with Red Hat OpenShift Orchestrator. The container network automation happens with an agent that runs on the controller and a CNI-based container plugin that runs on the host. So when a container is spawned, the networking for it is automatically taken care of across both the virtual and physical switches. Now, as we talked about earlier, given the dynamic nature of container deployments, this dramatic simplification of network operations is very essential. And visibility is a very important benefit that we get with this approach, as I mentioned earlier, because the network admins get a view of all the container endpoints, and troubleshooting becomes extremely simple. We have ability to get end-to-end visibility from one container to another. I'll go into a little more detail on that. And then so the entire experience that application teams desire to provision and manage networks at the speed of containers can now be achieved with this big cloud fabric unified physical plus virtual solution, and in conjunction with Red Hat OpenShift platform. Now let's look at some of the visibility benefits that the solution provides. So here you actually see how the solution provides container endpoint visibility to the network admins. So the OpenShift node is automatically detected. We can see that in the table, and it says it's auto-discovered. And it is connected to the lead switch to form a link aggregation group, as indicated in the list of member interfaces. And the BCF GUI also provides visibility into the container endpoints that are dynamically learned by OpenShift. You get details such as the container name, the description, the tenant segment information, and all network constructs such as the IP address, MAC address, the vSwitch, the vNIC, and all that. All of these dynamic information which we learned, the fabric learned from the OpenShift. So as you can imagine, all of these information in the hands of the network admins could be very useful for troubleshooting, as they have an inventory of the containers that are part of the network. Now, talking about troubleshooting, Big Cloud Fabric provides a valuable feature for troubleshooting known as test path. So with this, the network admins can do a connectivity test between any two container endpoints right from the BCF controller. It's a very simple operation. You just need to provide the source container and the node, and then the destination container node, and then what you get is an end-to-end fabric view of the path, and that is beautifully displayed in the GUI. So you actually see the path as the packet traverses to the virtual switch, the leaf, the spine, and then the destination leaf switch, the destination virtual switch, and finally going to the destination container. So this is only possible because of the unified architecture. The BCF controller manages both the physical and virtual networks, so you get the visibility from a single pane of glass. Provides excellent operational savings, as it completely eliminates complex box-by-box CLI hopping that is seen in traditional network troubleshooting. Finally, BCF provides analytics dashboard, which has historic report of all events, statistics, as well as customized information related to container networking. So the dashboard has a graphical view of all container events. You can zoom into specific historic time windows to get event details corresponding to that time window. And more details of the individual event can be found for specific events from this dashboard. So, overall, great solution in terms of automation for container networking, as well as visibility, and the integration with OpenShift really enables this automation. With that, I'll turn it over to you, Angelique. Thank you.
All right, thank you, Bala. Again, that was an excellent overview of the Red Hat OpenShift and Big Cloud Fabric solution, which, as Bala mentioned, provides incredible visibility, resiliency, and automation for container networking. So we're going to take an up-close look at this solution, and to walk us through a demonstration of it is Ganapathy. So I will turn it over to you.
Thank you, Angelique. Thanks once again for Bala and Azhar for providing insight into the joint solution we have. Let's experience this joint solution through our video demonstration for Big Cloud Fabric container networking integration for Red Hat OpenShift.
In this demo, I'll be walking you through following aspect of the solution. First, how BCF automates provisioning of Red Hat OpenShift cluster nodes to the network. to provide single pane of glass for both physical and virtual networking. Second, containerized application deployment using OpenShift container platform with Big Cloud Fabric container plugin to provide container network automation. Finally, BCF visibility features, test path and fabric analytics, which makes monitoring and troubleshooting of Red Hat OpenShift container networking easier and simpler. This is the BCF controller web interface, which is a single pane of glass for managing entire physical and virtual fabric. BCF fabric page provides the BCF topology. For this demo, we are using 3-rack BCF topology with 3 Red Hat OpenShift cluster nodes, which are connected to this Big Cloud Fabric. Bottom of the fabric page shows all 3 Red Hat OpenShift nodes, which has BCF virtual switch installed. These OpenShift cluster nodes are auto-discovered and managed by BCF controller for networking. If you mouse over the switches, it provides the switch name and connection details, OpenShift master node, node 1, and node 2. If you click on the switch, it provides additional details for that switch on the left. BCF also forms link aggregation to all the nodes dynamically. This can be seen on the BCF interface group page. As you see, cluster has 1 OpenStack master node and 2 agent nodes. All are auto-discovered and link aggregation is formed to those nodes dynamically, as you can make out from mode and auto-discovered column. If you click on each of these nodes, it provides the physical link connected to these nodes used for link aggregation. This is one of the key benefits of BCF solution, where all Red Hat OpenShift cluster nodes are auto-discovered and link aggregation is formed dynamically as you connect Red Hat OpenShift cluster nodes to BCF. No manual config required to provision the Red Hat OpenShift nodes onto physical fabric. Now let's look at the Red Hat OpenShift container platform web interface. Logging in as Project Red Admin. Project overview page lists all currently deployed applications. Project Red has 2 applications deployed, Redis Master and Hello OpenStack app with the 2 instances each. The way BCF plugin works is, as you deploy the containerized application using Red Hat OpenShift container platform, BCF plugin provides unique IP address to the container based on the network segment configured for that application. Then it attaches the container to the BCF virtual switch on agent nodes. And then BCF agent takes care of configuring BCF controller with relevant segment membership configuration for the newly deployed application containers. From network admin perspective, he or she would have full visibility into the container, and admin can continue to use current network operational best practices for container networking as well. Now looking at the BCF endpoint page, which provides the details about currently deployed application containers, which are dynamically learned and configured through BCF Red Hat OpenShift integration. This includes applications tenant and segment, container name and description, container IP and MAC, virtual switch or agent node where containers are hosted, and virtual NIC of the container. Now let's scale up the application instances and look at how BCF dynamically takes care of networking for the newly spawned containers. Now scale up Hello OpenShift application to 25 instances. Similarly, scale up Redis Master to 10. At this point, Red Hat OpenShift will spawn additional application containers to reflect new application pod numbers, and BCF plugin will take care of networking for this newly spawned containers. Now, BCF controller would have details about all new application containers, as you see from BCF endpoint table. These are dynamically learned and programmed through BCF OpenShift integration. Now, let's scale down application back to 2. As you see, BCF plugin has updated the configuration, and only 2 container instances of each applications are seen on BCF endpoint table. As you saw, BCF integration takes care of fabric config automation for container networking as you deploy, scale up, or scale down your application using Red Hat OpenShift. Now, with application containers deployed, let's look at the BCF monitoring and troubleshooting tools for Red Hat OpenShift container networking. BCF provides test path feature, which can be used for connectivity tests between 2 container endpoints from BCF controller with a couple of clicks, and no box-by-box troubleshooting required. Let me run connectivity tests between 2 OpenShift application containers, provide source container and destination container for the test, and provide application flow info. Once you run the test, BCF controller view provides connectivity test result for the given flow between the 2 containers. This provides logical and physical path for the given flow. And BCF Fabric View provides even more detailed physical path in the fabric for the given flow between containers, which includes source virtual switch, physical leaf, spine switches, destination virtual switches with ingress and egress interface details at each hop. For example, source container is hosted on OpenShift node 2 and shows the ingress virtual NIC and uplink used on the OpenShift node 2, which is ENP8S0F1. Similarly, at each hop, you would see ingress and egress interface for the given flow between container endpoints. Now let's look at the BCF Fabric Analytics for monitoring and troubleshooting BCF Red Hat OpenShift container networking. BCF Analytics provides the historic report of all BCF networking events and statistics. This includes container networking as well. BCF Fabric Analytics provides customized analytics dashboard for container networking. We click on Container Dashboard. This provides all container networking events. You can zoom into time window to get events specific to that time window. You can click on individual events to get more detailed info on that particular event.
Just to summarize, that concludes the demonstration of our joint solution. As you saw, Big Cloud Fabric container networking integration for Red Hat OpenShift essentially provides simplicity to the container networking, and the network admin can continue to use his current best practices for networking for container networking as well. And as you saw, we extend some of the troubleshooting and monitoring tools for the networking for containers as well. With that, let me hand it over to Anjali.
Thanks, Ganapathy. So we covered today the OpenShift Big Cloud Fabric solution, but we also have a number of other solutions that are integrated with Red Hat that we haven't covered today, but obviously you can find information on those on our website. We also have some integration with our Big Monitoring Fabric solution as well. So in terms of the OpenShift solution, I just wanted to call out the fact that we are OpenShift primed. Azar, are you able to give us a little overview of that program?
Yeah, very quickly. OpenShift Primed is a program that allows partners to integrate their capabilities with OpenShift platform. We go through significant amount of joint work in order to enable and provide an experience that's much more smooth at a very high level. There are lots of details on OpenShift.com with respect to what an OpenShift Prime capability is, but what we're really trying to highlight here is that this work that was done through Red Hat and Big Switch has really taken the entire conversation to a different level that allows you to now say, here's how you can deploy containers with a Big Switch fabric, and and provide a view into the system that's very, very powerful, very, very unique.
Great, thank you. So we now have time for a few questions that have come in throughout the presentation. So I'm going to start with a question for Azar, and the question is whether containers are applicable for NFV architectures, for example, running DPI applications.
Sure. There's a lot of work that's been done recently in terms of containerizing network functions, right? Virtual network functions. Some of the demonstrations you've already seen are around IMS applications. Some of the others are around vRouters and including DPI, deep packet inspection. These applications that typically don't rely on non-natted profiles. In other words, they don't care whether the addresses are natted or not, whether they don't care whether you need public address or full visibility into the network or not. Those type of applications are very, very easy to containerize, go ahead and deploy, and you saw the whole solution in the demo in terms of how easy it is. Typical web applications, again, becomes very, very easy. Applications or virtual network functions that require full exposure of network interfaces into the public domain, either assignment of public addresses. There, I believe there is some interesting work that has happened in the industry with respect to what we call as CNIs, container network interfaces, and plugins that are being developed to be able to allow that. You will see more and more of such solutions. There are multiple that exist. And you will see more of those come in the future. So net, yeah, you can deploy virtual network functions in containers, quite a number of them. There might be some limitations for a few, which you can easily overcome using CNIs and using appropriate level of plugins.
Great, thank you, Azhar. So we have a question regarding whether or not, so this is a question either for Ganapathy or Bala, if you would like to answer this. How is this networking solution different from the OpenShift default networking model?
Sure, let me take it, Bala. So I think Bala already talked about it during his presentation. Essentially, default model for OpenShift container networking is the overlay. You can use the overlay networking, which is based on VXLAN, to do that, which will have its own downside, like visibility gap, the penalty because of the NCAP, DCAP. So with our integration, as you saw, it's CNI-based architecture. We provide P plus V solution, so that way the network admin would have a visibility into the container networking. So that's how we differentiate from the default option to our CNI-based plugin, which provides P plus V networking.
Awesome. Okay. So we have time for a couple of additional questions. The first of those is, how does the BCF container networking solution work if the physical fabric is not from Big Switch? Looks like you need to have BCF at both physical and virtual layers.
Yes, that is correct. And again, as we talked about during the presentation, and as just Ganapathy mentioned, the value of our solution is in the unified aspect, right? We have both the physical and the virtual networks managed by the single controller. We are able to provide, visibility. We are able to provide automation of the entire network. So the solution has been designed so that it is a unified physical plus virtual network, and it requires the open networking switches running Switch Lite operating system, which is the operating system that we provide with our package.
Great, thank you, Bala. We're also getting a few questions regarding whether or not this presentation will be available after the webcast. Again, we will make that available on our website afterwards, so you can always refer back to it. There's a full webinar archive that you can refer to on our site. So with that, we're going to start to wrap up the presentation. Again, if there's anything that we've discussed here that's interesting to you or you would like to learn more, just head on over to our website at bigswitch.com, or you can send us an email at info@bigswitch.com. Again, for those of you who we were not able to respond to during this webcast, we will get your questions answered and also make those answers available to the folks who are watching the archived webinar. So one thing that I want to mention before we sign off is that we make it very easy for you to get started with Big Switch solutions. There are several resources that you can download or watch, and we also have BSN Labs, and this is where you can experience our open networking SDN solutions firsthand from the comfort of your own PC. So we believe that there's no better way to learn about a product or a technology than to take it for a test drive. So you can get this hands-on experience with our product by just going to labs.bigswitch.com to sign up and get access. And again, all of our past webinars, including this one, will be online at bigswitch.com/webinars. We also have an upcoming webinar on Wednesday, May 17th at 10 a.m. Pacific time with our partner ExtraHop. The title of the webinar is ExtraHop and Big Switch, Pervasive Application Performance and Security Monitoring. So please be on the lookout for an invite in the coming week. And with that, we will sign off for today. Have a good day.
Are we off live mode?
Yes.
Okay, thanks.
Hey, Azhar, thank you very much. It was awesome. Thank you for a great presentation.
Yes, also that was was very good. It came through really nicely on our end.
Thank you very much. No, you guys were really good as well. I mean, it was very smooth, very, you know, and the transitions worked really, really well. So Angelique, good questions, and thank you.
Thank you.
Fantastic, great collaboration, and I'll follow up with the email to the broader team. So really appreciate it, Azhar. Thanks for your time and, you know, for all the efforts in preparing for this.
Hey, pleasure's mine. You know, one thing we do need to do though is if you can share that OpenShift video recording, I would really have Red Hat leverage that more to show as part of their demo suites that they have.
Yeah, I think Ganapati sent you a link, right? But we can definitely.
Yeah, no, I have the link. I mean, I obviously I need some official permissions and stuff like that, right? So.
Sure, yeah. You feel free to share it within Red Hat, and we'll also share the webinar recording, right? That can also be an asset. I will share it with you, with Chris, and others in the.
No, I want to give it to our marketing team actually, and they'll probably connect with you to see how it can be further advertised.
Okay, perfect. That's awesome.
Sounds good. Thank you.
Thank you, Azhar.
Thanks.
Take care. Bye-bye.